Was first invented in the late 1800s can be found on the market today in many different forms with very different properties. Today, the soft hydrogel lenses highlighted in blue on the Ocular Surface Center Berlin's infographic are the most commonly used, silicone hydrogels representing 64% of the market, and standard hydrogels representing 22% in 2017, according to Contact Lens Spectrum. The ideal polymer to be used for contact lenses must be transparent, flexible, have low density, be tough, unreactive, but most importantly, A, be hydrophilic as to not disrupt the tear flow in our eyes and keep our eyes moist and comfortable, and B, be oxygen permeable as oxygen from the air is needed for proper eye function. In the late 1990s, the most commonly used contacts were invented. Silicone hydrogel lenses can allow up to 5 times more oxygen to reach the cornea compared to standard hydrogel lenses. Silicone hydrogels are made of a combination of silicone rubber and hydrogel monomers. The reason for adding these hydrogel monomers is that silicone rubber is very hydrophobic. The silicone rubber in question is polydimethylsiloxane, or PDMS for short. The silicone oxygen bonds have ionic character due to their difference in electronegativity of 1.54, making the bond polar covalent. The polar nature of this bond would make PDMS hydrophilic if it were not for the nonpolar methyl groups shielding the polar chain, preventing PDMS from bonding readily with water. The small difference in electronegativity of the carbon-hydrogen groups of 0.33 means only weak London dispersion forces are available as intermolecular forces, which is not optimal for the dipole moment-loving water to bond with. What gives PDMS its high oxygen permeability is the low intermolecular forces previously mentioned. These London dispersion forces result in a high amount of free volume and chain mobility. However, to use the high oxygen permeable PDMS in contact lenses, something had to be done to increase its wettability or hydrophilic tendencies. To accomplish this, scientists Mueller and Dicart combined PDMS with the hydrophilic monomers N-vinylpyrrolidine and 2-hydroxyethyl methacrylate, or NVP and polyhema for short. NVP's presence of nitrogen and oxygen allowed for hydrogen bonding, which means the monomer is very hydrophilic. Also, its asymmetrical structure lends to polar characteristics. Polyhema's asymmetry in its hydroxyl group increases the monomer's polarity and thus makes it hydrophilic as well. However, even these additions weren't enough to make a good contact lens, since the hydrophilic silicon and the hydrophobic silicon and the hydrophilic monomers had such a significant difference in chemical structure that they experience a phase shift, similar to what happens when you mix water and oil. The result was not a clear substance. The contact lenses we see today use techniques to control and limit phase separation so that light can shine through, making it clear enough for the user to see. So thank you for listening, and I hope you have a great day.